So example 4 is finding arc measures in circle graphs. So a lot of times when you've seen circles, you've seen them with percentages. So in this example, it says a recent survey asked females which sport they participate in. The circle graph shows the results. Find the indicated arc measure. So what we had seen in the first example is there'd be a measurement here in degrees, and that would be the same measurement as the arc. But now we don't have that. We have percentage. So it tells us that 20% chose basketball, 14 chose other, 14 chose soccer, 16 chose softball, 18% volleyball, and again 18% chose track and field. So we don't know how many people were asked. We just know out of 100% what percent voted for each. So this is pretty simple. To find CD is volleyball, which is 18%. So I'm going to take that 18%, change it to a decimal. If you remember, you move the decimal place over 2. So it's going to be 0.18. And I'm not going to multiply it by 100%. I'm going to multiply it by how many degrees the circle is. And a circle is 360 degrees. So I'm just going to take 18% of 360, which I get 64.8. And that is how many, that's the degree measure of that angle and that arc. So BC actually happens to be the same. So I'm going to get that same answer, 0.18 times 360. It's going to again be 64.8. EF is 14%. So I'm going to do 14% of 360. And I get 50.4, which makes sense. It should be less than the 18%. And lastly, EC, I'm going to add 16% and 18%, which is 34%. So I'm going to do 30.34 times 360, and I'll get 122.4. So the biggest error that people do when they convert is they take the percentage and they multiply it by 100, but we don't want it in percent. We already know how many percent. It's 18. So we want to multiply by 360 for all of them.